Hey everybody, welcome to 7.7 Statistics and Graphs. Today we're going to be learning about several different things. We're going to review mean, median, and mode, which you have learned before. I'm going to show you how to find some of those on your calculator though. We're going to talk about standard deviation. We're going to create box plots, histograms, and determine outliers. So some of this is review, but a lot of it will be new. So please watch the whole video. First of all, you have learned about mean, median, and mode before. You may not have known that these are called measures of central tendency. Measures of central tendency. And just so you know, statistics are numerical values used to summarize and compare sets of data. So the measures of central tendency tell you where the center of the data is. And I'm giving you some vocabulary words. You know right now you're probably going to need to start studying them. So make a note of that, measures of central tendency. Okay, so to find the center of data, the mean is the average. In this class, we're going to say the mean is this symbol right here, which is the X-bar symbol. We talked about that already a little bit in chapter 12. Review, to find the mean, you add up all your values, and then you divide by how many values there are. The median is the middle number when the numbers are written in order. And just so you know, if there is an even amount of data values, the median is actually the average of the two middle numbers. So sometimes the median is the very middle number, sometimes it's the average of the two middle numbers, and we'll work on that. And the mode is the number that occurs there the most often. There can be more than one mode, and there also can be no mode. All right. Then there is something called measures of dispersion. So measures of dispersion tell us how spread out the data are. And there's two that we're going to talk about in this class. The range, which is just the difference between the largest and smallest data value, so you just subtract them. And then the standard deviation, which describes the typical deviation between the mean and a data value. Okay, so the key thing that you need to know about standard deviation is a higher standard deviation means data is more spread out. So data that is close, all stuck together in a certain spot would be a low standard deviation. A high standard deviation means data is more spread out. This is a formula for finding it by hand. In this class, we're actually not going to be finding it by hand. We will be using our calculator, and I will show you how to do that in just a little bit. Let's get started. I'm going to review with you a little bit how to find these by hand, and then I'm going to show you how to use your calculator as well. So start by example 1. Will you please order the data from the smallest to the largest value? Go ahead and pause the video and do that. Alright, there it is, ordered from least to greatest. And sometimes, especially if there's a lot of data values, just to make sure that I didn't forget anything, I'll go through and count how many I have. So right now I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 in my list. And in the original list, there were 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so 11 and 11, so then I can be sure I didn't miss any. Let's go ahead and find our stuff. So a range was the high, subtract the low. So 8, subtract 1, my range is 7. The median is the middle value. Now in this case, there are 11 data values, which means that my median is going to be a specific number. It's just going to be in the middle. So there's 11 values, so there's going to be 1, 2, 3, 4, 5 on either side of my median. 1, 2, 3, 4, 5 on this side, 1, 2, 3, 4, 5 on this side. Some of you may have in middle school learned the cross-off method where you just kind of cross off to go through and find the middle. That's fine if you want to do that. Okay, mean, add them all up, divide by 11. I am so nice, I added them up for us earlier. These all add up to be 44. And then I already said there's 11 values total, so divide by 11, my mean is 4. Last but not least, let's find our mode. Again, there can be no mode. In this situation, there is a mode though, because there's 3 4s, and that's the most of any type of number we've got. So the mode is 4. Alright, and now we're going to find our standard deviation, and I'm going to show you how to enter this data in your calculator. And just a note, the mode, our calculator does not calculate mode. So as soon as we do this, if you're wondering, the calculator does not have the mode. Alright, I'd like you to try this as we go along here. Here's how I enter my data. First, To enter my data, you are going to hit the Stat button. So open up your calculator, and then the Stat key, as you can see, is right next to the Variable button. There it is right there. Let me get my calculator on. Okay, there we go. So your screen looks like this. In order to enter my data, I want to select number 1, Edit. What that does is it brings us to the statistics table of values where I can enter things. So I am going to select number 1, Edit. And now you can see in my calculator I already have data values. Some of you may also have data values already. The program that we're going to use to calculate these values uses the first list. So if you look at the top of your calculator screen, it should say L1, L2, L3, and so on. We always want to enter our data into L1. If you already have data there, to get it off, scroll all the way to the top and hit Clear and scroll down. Now please hit Clear, because if you scroll to the top and hit Delete, it's going to delete the entire column instead of just the numbers. So hit Clear and scroll down. Do not hit Delete. Alright, I am just going to go ahead and enter in my data. I'll pause the video, so pause, enter your data, and then unpause when you're ready. Alright, I've got my data entered, and another quick check you can do for yourself is in the calculator it actually tells you which value you're up to. So here I'm up to the 11th number, and I know there's 11 numbers in my list. So that's another way I can check to make sure I didn't forget any when I'm entering these. Next we're going to calculate the stuff we want to calculate. So I am going to hit the Stat button again. To get to the Calculate menu, you scroll over to the right where it says Calculate at the top of the screen. Look. And we are going to select number 1, which says 1 var stats. That stands for 1 variable statistics. And after you select that, hit Enter in order to run the program. And it'll give you this output here, and you can scroll up and down to view the different things it's given us. So later on in this section, we're going to talk about this data at the bottom of the list, the minimum, Q1, median, Q3. Actually, we've already talked about median. MED stands for median. If I scroll back up, I can see that the very top of the page has X bar. The second thing in the statistics output is they have found, remember that from, well, we're going to talk about this in chapter 11, I guess, but this letter right here, this weird looking E, it means sum. So they just found the sum of all the values, which is 44, which is the same thing we did when we did it by hand. And then here they've squared that, and there's this SX and this sigma x. They're both standard deviations. There's 2 different types of standard deviations you can use. In this class, we're using the one with the little weird shaped O. So our standard deviation is 2.09 if we round it. So 2.09, and we will always round to 2 decimal places. I'll be doing the calculator entry again one other time during this lesson, so if you didn't quite catch that, I will be doing that again in example 4. And we can work on it in class as well if any of you didn't get that. Alright, so let's move right along then. And 2.09 doesn't really mean anything to us because we haven't studied standard deviation very much. Standard deviation really will mean something to us when I can compare some. So let's look at example 2. It says in the 1998 season of the WNBA, the Eastern Conference free throw percentage data had a standard deviation of 12.3. The Western Conference data had a standard deviation of 11.7. And then which set of data was more spread out? Okay, so again, the higher the standard deviation, it means it's a greater spread of data. So from the lowest to the highest, it's more spread out. The Western Conference was less spread out. So which one was more spread out? The Eastern Conference was more spread out. I have some information from you below here that is about box plots. I'm going to just go through and read it. So a box and whisker plot, review from middle school. It's a graphic summary of the data, so it gives you a picture of what the spread looks like. There's a box that encloses the middle half of the data set, and then there's some lines that extend to the minimum and maximum, and that's where the whiskers come in. So the 3 main things we find here is the second quartile or the median, the lower quartile and the upper quartile, and the first or called lower quartile, it's the median of the lower half of the data. So if I was finding this by hand, I would go through and find the median of the lower half of the data set. The third, or upper quartile, is the median of the upper half. Flip to the next page. We're going to first create a box plot just using the same information we had from example 1. And again, one more item I should tell you. The points and the lines are graphed below or above an evenly spaced number line. So your number line has to be a true number line, whether you label it 5, 10, 15, or whether you label it 1, 2, 3, doesn't matter, but it has to be a truly spaced number line. Sometimes I see students just put like 5, 12, 20 on their number line because those are the 3 points that they're using. That doesn't work. You have to have a real number line there. Alright, so I already have our data set listed for us. We found out earlier the median is 4. So I want to show you if I was going to find the first quartile by hand, if the median is a specific number, it's not included when I talk about the lower half of the data, and it's not included when I talk about the upper half of the data. So here's the lower half of the data, and the middle of the lower half is 2, so that's my quartile 1. The middle of the upper half is 6, so that's my quartile 3. Oh, I put that in the wrong place though. Here we go. And then the second quartile is the same thing as the median. And that's 4. Alright, min and max, same thing we had before. And so here's what my box plot looks like. Above or below my number line, I have a dot at the minimum, a dot at the maximum. I'm going to have vertical lines at the first quartile, the median, and the third quartile. In the middle here, a box goes around that data, and I put a line out to either side. We're going to talk about more about this in class, but because they're called quartiles because specifically they split the data into quarters, which means 25% of your values are in this region, 25% of your values in this region, 25% in this region, 25% in this region. Alright, the next thing I want to talk about today are histograms. So you are probably all familiar with creating bar graphs from middle school. A bar graph has space between its bars and a histogram does not. And also, a bar graph is usually just a specific count of things, but a histogram, we use intervals. So a histogram can be used if you have different, for whatever reason you want to split your data into different intervals. For example, if I was going to make a histogram of student test scores, I wouldn't want to make a bar graph because I wouldn't want to have a bar for each test value. I want to know how many students got between a 90 and 100, how many students got between an 80 and a 90, how many students got between a 70 and 80. Those are intervals. I have some data here from 1997 through 1998 again, really old data, but here's, it's from the Eastern Conference of the NHL. Okay, this is how many games the different teams won. Here's what we do to make a histogram. First of all, you split your data into different intervals, and you can make your intervals whatever you want normally, which is one way that people can do funky things with statistics here. I specifically this time want our data to go from 11 to 20 and then so on. So I'll go from 21 to 30, 31 to 40, 41 through 50. And for what we're doing in this class, I'll usually just tell you what interval to use. And now here's what's going to happen. I'm going to go through my list of numbers and I'm going to make a tally. So for example, 36, that goes in the 31 to 40 range. So does 39 actually, and so does 40. So does 34. Okay, 48 goes down here. I'm going through and I'm just tallying up where my data falls. 30. I like to cross off values as I go to make sure I don't miss one. Now if you're working with a book, you're going to have to write in pencil and erase it because you can't write in pen in the book. There we go. And so I made a tally of all my responses. I do it that way just because then you don't miss a value. It's faster. Here I'm just going to count how many in each category I've got. So 1, 3, 7, and 2. So there is 13 responses total if I add those up. Now we'll make our histogram. So for your histogram, you always want a title. In this situation, we're working with the Eastern Conference. On the side, I'm going to write what I have, what those numbers represent. In this situation, these represent how many teams, the count of teams that fell into each interval, and my intervals are the number of games won. The number of games won. And then I write my intervals down here, and it seems weird, but it's okay if you don't start right at 0. So it's okay for me to say, okay, 11 through 20 right away. I didn't have to say 0 through 10. 21 through 30, 31 through 40, 41 through 50. And now my bars are representing the count of teams. So this bar that goes up to 1 represents one team won between 11 and 20 games. 3 teams won between 21 and 30. 7 teams won between 31 and 40 games that season, and 2 teams won between 41 and 50 games that season. My bars are a little off, but there we go. So if I gave this data to someone, I have no idea how many specific games teams won. All it shows me is that most teams won between 31 and 40. And there's pros and cons to using this method of display instead of a bar graph. And we're not talking about that very much in this class. But we will talk about that a little bit when we talk about appendices 3 and 4. When you're finished with your bar graph, or wow, your histogram I mean, you can flip to the next page and we're going to talk about outliers. Pause the video if you need to finish it though. Alright, so you've all heard of something called an outlier. It's something that's very far away from the rest of our data. There is a specific mathematical way I can calculate an outlier, and there's actually more than one formula. So the formula that we're using in this class is right here. I find what the mean value, the average value, plus or minus 1.5 times the difference between the quartile 3 and quartile 1. And then if my value is above or below that, it is an outlier. I'm going to teach you how to use that formula in a minute, because just looking at that probably doesn't mean very much to you right now. And I also want to tell you that the reason that we care about outliers is if I'm finding an average, one outlier can really affect what the average of something is, especially if you're talking about something like house prices or annual household income. That's why a lot of data in our US, if you read the newspaper or something, they always talk about the median. If you've been listening to the election in 2012, they always talk about how the median household income decreased by $4,000. They always say median because then it's not affected by the outliers. Because if I found the average, it'd be way higher because it'd include all those millionaires. We'll talk more about that in class as well. But let's look at example 4. And what we're going to do first is we're going to find a bunch of our values. So the range, mean, median, mode, standard deviation. Remember, the mode cannot be used, can't be found on the calculator. That one I have to do by hand. And the range is not really on the calculator either, but I can find it. I'll show you. Here's what we're going to do. So go to your calculator again. Now, remember, you're going to hit stat, which is right next to the variable key up here. Edit, and then I need to clear my data. So remember, scroll all the way to the top and hit clear. Do not hit delete. Do not hit delete. Hit clear, otherwise you'll delete the whole column. And now I'm ready to enter my data. So please pause the video, enter your data. When you unpause, I'll have it all up here. Now this time it also says right in the example, quiz scores from an algebra class of 20 students. So I don't have to sit there and count how many values I have. It's told me there's 20. So look at my calculator. I'm at the 20th spot when I hit enter my last value. So I'm good to go. Alright, once you have your data entered, and I have it entered under L1 in order to use this one variable statistics program. I'm going to hit stat again, scroll over to calculate, and select number 1, one variable statistics, hit enter, and it gives you your output. And so this time I'm not going to find my mean and median by hand, I'm just going to use my calculator. So starting with the top, the x bar, or the mean, is 7.95. The next value I use is the standard deviation, which again is this weird shaped O, so that's let's say 1.9. Scroll down. The minimum is 1, maximum is 10, so 10 subtract 1 is 9 for my range. The median is 8. And again, mode it doesn't give us. And then I'm going to create a box and whisker plot in a minute, so I'm going to go ahead and just copy down all these really quick just to make sure that I've got them. So Q1 was 7, Q3 was 9, and the max is 10. So that's what I need to make my box plot too. Alright, let's figure out our mode. So for the mode, I'm going to count up how many there are, and just by eyeballing this list, it looks like there's a lot of 7s, 8s, and 9s. So just by looking at it, I'm not sure what's the highest. I'm going to count them up. So there's 1, 2, 3, 4, 5 7s. There's 1, 2, 3, 4, 5, 6 8s. There's 1, 2, 3, 4, 5 9s. Okay, and there's only 3 10s and only 1 1, so it has to be the 8s. So the mode is 8. Alright, we're going to draw our box and whisker plot now. And remember what I said, we have to have a real number line. So if I'm going with my data from 1 through 10, I don't know if I'm going to have enough tick marks to go from 1 through 10. So it is fine to label it something like 2, 4, 6, 8 instead. And when I draw my dots, they're just not going to be on specific tick marks, and that's okay. That's what happens with a box plot. So for my box plot, minimum is at 1. Median is at 8. Q1 is at 7. Guess I should have done that first. That's okay. Q3 is at 9. And the maximum's at 10. So there's my box plot. Go ahead and make sure you have that written down correctly. It next says for us to draw a histogram, and are there any outliers? Just by eyeballing it, I think 1 is an outlier, but we want to prove it mathematically. You know what? I'm actually going to do the outliers first, then we'll go through and make our histogram. So here's what I meant by this formula right here. I am going to calculate this, the mean plus or minus 1.5 times Q3 minus Q1, and then that's going to give us basically a range, and if anything is outside that range of values, it means it's an outlier. So let me show you. Alright, so I'm looking for the mean plus or minus 1.5 times Q3 minus Q1. Alright, for my data, the mean was 7.95. Q3 was 9 and Q1 was 7. Now, 9 minus 7 is 2. 2 times 1.5 is 3. And here's what this means. I am going to take 7.95 minus 3. 7.95 minus 3 is 4.95. I'm going to do 7.95 plus 3. And so basically this gives me the low end of where to look for outliers, and this gives me the high end of where to look for outliers. And what this means is any value that is below 4.95 or above 10.95 is an outlier. So then I would look back at my data. Do I have any values below 4.95 or above 10.95? And yes, I do. 1. Someone had a quiz score of 1. So 1 is an outlier. It is below the range that I was looking for. So I'll say yes. 1 is. And then one more comment, and then we'll make the histogram and be done. When I look at this, that's what this was. That's what this meant. The value is further away than that, so greater than one of them and smaller than the other one is what I was looking for. Alright, I am going to make my histogram now. And I told you to make 5 intervals starting with 1 through 2. So my intervals are going to be 1 through 2, 3 through 4, 5 through 6, 7 through 8, 9 through 10, and it's difficult with my screen to go up and down while I'm tallying, so why don't right now you go through and tally how many of our values go into each one of these spaces. We're still using the same data from example 4. I'm going to pause. When I unpause, I'll have it all tallied up as well. Alright, I got 1, 11, and 8. Hopefully that's matching what you got. So this time I'm doing quiz scores. And you know what? I don't know if I have enough tick marks to go all the way up through 11. Maybe I do, but let's say I'm too lazy to count, so I'm going to go like this. And again, same thing with histograms, like the number line. Wow, the number line. You don't have to do 1, 2, 3, 4, 5, 6. You can do 2, 4, 6, 8, whatever. That's fine. So, and that is representing how many students got each quiz score. So I'll say student count there. I'm going to put the scores on bottom. My title of my graph is quiz scores. Quiz scores. And so on bottom, my intervals are 1 to 2, 3 to 4, 5 to 6, 7 to 8, and 9 to 10. And then I'm going to draw my bars in. So 1 is the first one. 7 to 8 had 11. 9 to 10 had 8. And that's it. Make sure you have that down, and thanks for watching.